Hi, this is Tim. Welcome to the Math League YouTube channel. Today we're going to be doing a problem from the 12104 sprint test. Now this is a high school test that was given out in December 2020 and January 2021. This is actually a problem that we intended to demonstrate at the contest itself, but we ran out of time. So we promised you it would be up on the YouTube channel, and here it is. All right, so with this problem, basically what you want to do is take advantage of the logarithm rules that you know. There are a few rules that are useful to know for dealing with logarithm problems in general. Let me go ahead and write down a couple of those on the board for you. All right, so these are the two rules that we'll be taking advantage of for the most part here. Let me just quickly introduce those. First off, you'll notice that when I don't indicate a base for a log, that means it's true no matter what the base is, right? It doesn't matter whether this is log base 10 of a times b equals log base 10 of a plus log base 10 of b. It could be the natural log of a times b equals natural log of a plus natural log of b. All right, so it works for any base. Here, if you have a specific base, the log base a of b, we can write as log of b over log of a. And this, again, is in any base, right? We can say log base 10 of b over log base 10 of a. We can say it's the natural log of b over the natural log of a. We could even say it's the log base a of b over the log base a of a, which just reverts back to log base a of b when you cancel out the bottom. Once we have these tools, we'll be able to attack the information that we have here quite easily. So we're going to start off with x1. So we've got 100 log base 2 of x1. What I'm going to do is I'm going to write that as a log of x1 over log of 2. And that equals, I'm going to use my change of base formula on the other side as well, log of 2x1 over log of 4. Once I've done this, I can actually change things around a little bit. Now, I've got logs. It's all the same base. Doesn't matter, again, which base you choose because it's all going to go away in the end anyway, right? So we're going to do a little bit of manipulation. If I multiply both sides by a log of 4, then I'm going to bring a log of 4 over to this side, basically. And you'll notice I have a log of 4 on the top and a log of 2 on the bottom. All right, let me just write it out like that. Log of 4 over log of 2 times 100 log of x1. Log of 2x1 is going to be log of 2 plus log of x1. Log of 4 over log of 2, that's going to be the same thing as log base 2 of 4, which is just 2. So I've got 2 times 100 times log x1. So that's 200 log x1 equals log of 2 plus log of x1. Now, look at the log of x1s that we have. I have 200 of them on the left-hand side and one of them on the right-hand side. I'm going to subtract a log of x1 from each side. And we see that 199 log of x1 equals the log of 2. All right, now this would be a good point for us to stop and take a look at what we're supposed to do here. Ultimately, the problem is asking us to compute log base 2 of x1 times x2. Now that's the same thing as log base 2 of x1 plus log base 2 of x2. So what I need to do at this point is to figure out what is the log base 2 of x1. I can get this from the information that we have here. Right, if I divide both sides by log of 2 and I divide both sides by 199, I see that the log base 2 of x1 is 1 over 199. Let me clean up the board here. I'll put this information up at the top, and then we'll start on the second set of equations. All right, now that I've got this, the second one should be even faster because we've already done most of the work in a similar manner. So let's go ahead and write this out as negative 100 log of x2 over log of 2 equals log of 2x2 over log of 4. All right, once again, I'll bring my log of 4 over here. That's going to cancel with the log of 2 on the bottom to give me a 2. So I've got minus 200 log of x2 equals, and then I have this part up here that I'm going to split out into a sum, the log of 2 plus the log of x2. Oh, I've got negative 200 log x2 on the left. I've got a log x2 on the right. Subtract a log x2 from both sides, and I get minus 201 log of x2 equals log of 2. All right, same as before, we're going to divide both sides by log of 2 because ultimately we need log base 2 of x2. Divide both sides by negative 201, and we see that the log base 2 of x2 is minus 1 over 201. All right, let me bring that up to the top of the page, and we'll finish out the problem. All right, now we can see that we have log base 2 of x1 and we have log base 2 of x2. They're asking us to compute the log base 2 of x1, x2, which is the log base 2 of x1 plus the log base 2 of x2. And we have log base 2 of x1, that's 1 over 199. And log base 2 of x2 is minus 1 over 201. All right, at this point, it's just a matter of doing the calculation. So I'm going to multiply the top and bottom of the first fraction by 201. And I'll multiply the top and bottom of the second one by 199. And what we get is 201 minus 199, or 2, divided by 201 times 199. Well, 201 times 199, that's 200 plus 1 times 200 minus 1. So it's 200 squared minus 1 squared. In other words, it's 40,000 minus 1, or 39,999. And a 2 in the numerator. There's our answer. And that's how it's done. Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.